Now for the last FRQ question. This is a 4-pointer, and we look over this page and we see we have an A, B, and C. Somehow we're going to have to get 4 points in this. We've got a calculation, yeah, a point. Describe an experiment. Okay, that's going to require some writing. And then C, what wavelength? Okay, one answer. So let's start with 7A. We've got a student with 100 mLs of a 4/10 molar copper sulfate solution. That's a blue solution. And is asked to make 100 mLs of 0.15 molar copper sulfate, 4/10, 100. And we need to make 100 mLs of 0.15 molar for a spectrophotometry experiment, colorimeter color solution. The following laboratory equipment is available for preparing the solution: a balance, weighing paper, funnel, 10 ml beaker, 150 ml beaker, 50 ml grad, 100 ml volumetric flask, 50 ml beer, and distilled water. Okay, that's a lot. I'm sure we won't be able to use all of that. Calculate the volume of 0.4 molar copper 2 sulfate required for the preparation. Now we need to find a volume of this 0.4 molar copper sulfate to make 100 mLs of 0.15 molar. Well, that's our classic equation where we take one concentration times the volume of that concentration, and when we dilute it, our new concentration and our new volume. Here, we want to make 100 mLs of 0.15 molar. And we need to find the volume of 0.4. Let's write it out because we've got to show our work and make sure we have things organized. We've got our more concentrated solution. We want to find its volume. And here's our new solution, 0.15 molar, 100 ml. You probably don't need to write out the algebra for this, but I put it down here just to show what's being done. So calculator time. It's going to be the 0.15 molar times 100. Divided by the 4/10. 37.5. Our unit is going to be milliliters. That makes sense. We don't need as much volume of this concentrated to make the diluted. So it's a logical answer. I'll accept that. So let's see. Did we answer the question? We calculated the volume of the 4/10 molar. Yes, 37.5. We use units, milliliters. It makes sense. So we've answered the question. We've shown our work, and we get a point for the correct volume. Great! 1 point. 3 more to go. On to B. Well, it says briefly. Okay, good. That's good because there's only 4 points on these things, so we don't want to spend a lot of time on it. Briefly describe the essential, so brief, essential, to most accurately. Okay, accurately is important here. Prepare the 0.15 molar copper sulfate solution from the 4/10 molar copper sulfate solution using the equipment listed above. We're going to have to take and get 37 mLs of the 0.4 to make 100 mLs of 0.15. Well, the equipment listed above, there is quite a bit of equipment there. I mean, if you listed that, say, whoa, oh, yes. And, you know, a chem lab has lots of equipment. This would be a college chem lab. You've got spectrophotometers, balances, all sorts of neat glassware. It's worth taking a chem lab course just to walk into a room with all this stuff. But let's get back to our problem where we have a list of equipment. Well, this is solutions, so we're not going to need a centigram balance. We're not going to need weighing paper. Funnel, maybe. 10 ml beaker, 150, graduate cylinder, volumetric flask, distilled water. We're going to need that to dilute, most certainly. So let's look at this equipment because we have to be accurate. Here we've got typical volumetric ware, beakers and flasks, which are not very accurate. So forget the beaker and flask because we need some accuracy. Intermediate accuracy are graduate cylinders, but our highest accuracy are burettes, pipettes, volumetric flasks. So they wanted accuracy, so forget the beaker and graduate cylinder. The other things that they listed, let's go back to that list and do some crossing out. The beaker isn't accurate. The beaker isn't accurate. Graduate cylinder, not as accurate. 50 ml burette, that's the accurate item. So a volumetric flask and burette, we know those are accurate. You should know that volumetric flasks can produce a specific volume. Well, we had a 100 ml volumetric flask, needed 100 mLs of solution. You pour the solution in here to the line and you get an exact volume to 1/10 of an ml. And if you want to have variable amounts of solution, either pipettes or the ancient burette, and they gave us a 50 ml burette, and we can dispense 37 mLs from that. So with a volumetric flask to get to 100 mLs and the 50 ml burette to measure out the 37.5, because we have to measure to the 5/10 of an ml. Here's what we do. To get our 35 mLs of 0.15 molar copper sulfate that we need to dilute, and we need to get it down to 100 mLs. So use the burette to get 37.5 mLs of copper sulfate into the volumetric flask that we can dilute, fill to the mark with distilled water. That's all we need to do. You could have tossed in a funnel in there, but no, I wouldn't do it. Let's keep this simple. Briefly describe the essentials steps. Burette to get 37.5, put it into the volumetric flask, fill with distilled water. One sentence, and we're fine. We've come up with the answer to this problem, and let's make sure, briefly describe the essential steps to prepare using the equipment above. So we use the equipment, burette, and volumetric flask, and we described what to do. In terms of grading, this is interesting. They gave you 1 point for measuring a 37.5. That's what they wanted to know. Does this person know that a burette can measure out 37.5 mLs of solution? And 1 point for knowing that a volumetric flask can get you 100 mLs very accurately. These two accurate pieces of equipment in terms of accuracy, beakers and flasks, almost none. Intermediate graduate cylinders, yeah, to an ml, but if you want real accuracy, burettes, pipettes, and volumetric flasks, eudiometers for collecting gas, but I'm not sure AP would be dealing with that anymore. We've just answered A and B. Things make sense. We can say 1, 2, 3 points. Only one more left. Okay, that'll be the next video. So go to my website and find the last question on this FRQ.